Light has this prettier murmuring light.
I'm recording the process.
You don't realize that she's laying. What do we do after? Like, I just started like shaking it a bunch of Libby,
Alright, this is frame check for multiplying binomials. I gotta make sure my head's in the right place in front.
Yeah.
So like I'm a little bit shoving off my head a little bit, so I gotta move my seat over.
This is tense.
Alright, frame check number 2 for multiplying binomials.
Wait, so you're on a knee the whole time?
What's that?
He's got a little chair.
Oh, I can't see it.
Yeah. I used to use, like, you would think, just use a chair, right?
That's too
But,
tall.
yeah, if I sit in a chair, then it's like it chops off half of my head. Which wasn't the worst thing in the world, but I figured if I just use a chair, then...
I thought you were always standing up in the video.
No, I'm sitting down.
I will be quiet. It's live.
Okay, this video is on multiplying binomials. And I'm going to start out by talking about the distributive property, which we're all familiar with. And if I want to use the distributive property to multiply these two numbers here, 7 times x plus 2, then I'll just take 7 times x, which is 7x. My marker doesn't work. Come on.
Come on.
Alright.
Dude, that was pretty good.
Huh? For 3 minutes now.
Okay, in this video we're going to talk about multiplying binomials. And I'm going to start by talking about using the distributive property to multiply two expressions. So I want to multiply 7 times x plus 2. And to use the distributive property, I'm just going to multiply 7 times x and 7 times 2. So 7 times x gives me 7x. 7 times 2 gives me positive 14. And I'm done. Well, when you're multiplying binomials, you're still using the distributive property, you're just using it in a slightly different form. So I could rewrite this expression, instead of writing it as 7 times x plus 2, I could write it as, if I write 7 as 3 plus 4, then I could write this as 3 plus 4 times x plus 2. It's the same thing. Well, now though I've got two terms here, basically 3 and 4, that I need to multiply by, which means I've got to multiply x plus 2 not only times 4, but also times 3. Well, so what I'm going to do is I'm just going to kind of do them, I'm going to do them in order. First, let me do 4 times x and 4 times 2. So that would be 4x and 4 times 2 is 8. Then I need to do the same thing with my 3. That is, I need to say 3 times x and 3 times 2. So 3 times x is 3x, and 3 times 2 is 6. Well, now if I just collect up all my like terms, 4x and 3x is 7x, and 8 and 6 is 14, and I get the same thing that I got before. This is all you're doing when you are multiplying binomials. You're just using the distributive property. So let's take a look at how we might use that if we're going to multiply two binomials that are actually, what you normally see, which is two algebraic expressions. So I'm basically going to do the same thing that I did before, which is I'm going to multiply this one times this one times this, and this one times this, and this one times this, which means I'm going to have, and let me just do it the same order I did before. 4 times x is 4x. 4 times 2 is 8. X times x is x squared. And x times 2 is 2x. And then again, if I collect up my like terms, in this case I only have 2 like terms, my x terms. So that's going to be 4x and 2x is 6x plus 8 plus x squared. And typically you write it with the highest exponent term first. So I would rewrite this as x squared plus 6x plus 8. And now this is basically where the FOIL method comes from. You may be familiar with the FOIL method. FOIL just stands for first, outer, inner, last. And that's just a handy way to remember all the different multiplications that you have to do. And you don't have to do them in this order, but it just makes a nice, mnemonic to remember how to do the multiplication. So if I'm going to do this using FOIL, x plus 4 times x plus 2, well, first I would multiply my 2 first terms. That's my first term. So x times x is x squared. Then I would do my 2 outer terms. That's x and positive 2. So that's going to give me positive 2x. Then I would do my 2 inner terms. Positive 4 times x, that's positive 4x. And then I do my 2 last terms, which is x and 2. So that's going to be, oops, x squared, 2x squared. Oh, my 2 last terms would be 4 and 2. So 4 times 2 is positive 8. Again, I collect up my like terms here, and I get x squared plus 6x plus 8, which is exactly what I got before. Now, I can also do this same multiplication using something called the box method. And for the box method, you just take your 2 binomials and you write them along the sides of this kind of 4-panel box here. So I'm going to put x plus 4 on the top and x plus 2 on the side. And then I'm going to fill in each one of these squares here with the product of each of my terms. So x times x, that's x squared. X times positive 4, that's positive 4x. X times positive 2, that's positive 2x. And positive 2 times positive 4, that's positive 8x. Often, it's helpful to write in front of the terms, the actual sign of the term, just to make sure you keep all your signs straight. So positive x times positive x is positive x squared. And now, I've got all of my terms here, and I just want to write them all down. So that's going to be x squared plus 4x plus 2x plus 8. And again, I collect up my like terms, and I get x squared plus 6x plus 8. So let's do one more example here. Here I've got one where I've got a negative sign, because I want you to see what happens with the negative sign. So I'm going to do this with a box method. I draw my box here, and I'm going to put, it doesn't really matter which one you put on top and on the side. So let me put x minus 3 on top, and x plus 8 on the side. And then I just multiply to fill in my boxes. X times x is x squared. X times negative 3 is negative 3x. Positive 8 times x is positive 8x. Positive 8 times negative 3 is negative 24. And I just write down my terms here. X squared minus 3x plus 8x minus 24. And I collect up my like terms. So I got minus 3x and positive 8x, so that's going to be positive 5x minus 24. Done.